The next talk is going to be presented by my co-chairman here, Francesco Celani, one of the pioneers of this field and one of the most imaginative experimentalists that I know.
Okay, can you start, Michael?
You may.
Okay, so my talk is a little bit unconventional because we make in a way a further progress or developing of what we show both during 1996 and in the last conference in Assisi. So we mixed together both effects. So we were maybe pioneering the pulse approach about hydrogen, deuterium, metal system, palladium usually. And we published a quite nice, important paper in 1996 in LENR-AHE, where we show that the first time it is possible to have HS power using very high frequency pulse of 1 megahertz rise time or less or more. So we move from an electrolytic system to gaseous system, and we change from palladium, very, very costly, to copper nickel alloy, Constantan. Work 40 degrees up to 800 degrees. So we make a lot of jump about. For the new experiment, we use at the same time several well-known effects in the history of science. So Richardson, it means emission of electrons just due to the temperature. Child-Langmuir effect, it means acceleration of electrons using a proper high voltage. And the Pascal or directly barrel discharge effect, it means at the proper high voltage and pressure, this is range about, there is ionization of gas inside the reactor. So we started from the previous coaxially-coiled geometry that we did develop and shown during a CC workshop. And in this experiment, we show that applying a weak transversal high voltage, just 50 Hertz and a few milliamperes, it was possible to increase and make longer the effect of anomalous heat effect. So it was the starting point, and now we moved to a more intense system because we shown again and again that the non-nuclear condition is the key point to have an anomalous heat effect. So we make at the same time a longitudinal electromigration because high power pulse, and using the counter electrode, we have quite large skin effect, and this skin effect, the electrons can be accelerated to other cathode. And moreover, using the Pascal regime, we can have a surface activation of the material because over time the system is damaged, so the exchange energy goes to zero. And during this experiment, we found unexpected, very useful achievements. So it is possible to activate the material. Activation of the material is one of the key points in the cold diffusion experiments, but it was just for a chance. The experiment is quite complicated, so I will give some short about the history of our work, its background information. So we have electromigration, or better to say even coherence due to the large voltage along the wire, but this condition needed the coherence of the system. It was claimed from Professor Preparata. Electromigration is more old effect found in 1928 from Alfred Cohen and collaborators in Germany. In the last 20 years, we moved from palladium system to other more cheap material like nickel or nickel alloy better from 2011, and especially Constantan because can work at very high temperature, up to 900 degrees, and work both with deuterium and hydrogen. And is a low cost material. So we found that sometimes we get a chest heat in the Constantan if only if is activated. The activation is the most difficult task in this field. So we don't have really a new procedure, through method. We just try several things. But when the material changed something, we have some idea about, we have a chest heat if we have enough high temperatures, large temperature gradients along the wire. The surface is sponge, so we have a lot of surface, and coated by low working function materials, means materials that are able to emit electrons easily due to a high temperature. And there is a flux of atomic or ionized deuterium in the bulk using high voltage or pulse, or in the surface we have activation. Other point is even if we are able to get a chest heat, we have seen that over time the system go always to zero. So we need a way to make younger again the surface of the material or maybe the bulk. See now not clear why. And but this has to be done in situ without opening the reactor. And other points, the non-equilibrium need some extra energy added, but we want to have a true gain, so we have to minimize the extra energy added to have non-equilibrium. So using a word used in the terminology, we have to make the full account of energy in the system, like from the well to the wheel. Our system moved from the first one, very simple, in 2011 A-type, to more recent, which is the coil and high voltage peak. So it's quite complicated, like it's shown in the last point, A point. The reactor geometry is a coaxial coil, so because it's inductive and high frequency, we have also a Pascal effect. This Pascal effect in some way concentrated the energy only of the surface of the wire. High frequency effect. And moreover, we need to have high voltage to allow moving of the electrons in the Richardson regime, or ionization of the gas. So we need always high voltage. And the material is made by multi-layer coating using strontium, iron, potassium, manganese. And the multi-layer procedure for the preparation was pioneered from Professor Iwamura in Japan since 1998. The reactor is just a coaxial wire, coaxial cable, but reversed. It means the reference is in the inner, so the screen is inner, and outside there is the wire put inside a insulating sheet of specific glass. The glass sheet is a key, one of the key points of our system, because it has to be porous to high voltage, but not too large hole, otherwise we have the destruction of the wires because I control the sparking. This is still open problem. Here's some more detail about our structure. We have at the same time Richardson operation, Child-Langmuir, and Pascal dialectics in Pascal to have gas breakdown. We have, because pulse, very, very large electromigration values just using the simple Cohen effect, the order of 2-3 electron volts per centimeter. Usually it's electromigration is 0.3, 0.5 volts. So 4-6 times larger than the usual. Moreover, because of quite complicated tight time, we need to have a firing of the system with time delay very short, less than 100 nanoseconds, and with the modern device, it was possible. Here is a schematic of the pulse, a little bit complicated. It's based on a capacitive discharge system, but with the peculiarity to have high efficiency even at a large repetition rate. Usually this system is very efficient, up to 1 kilohertz of repetition rate, but after the efficiency drop a lot. But we had a special circuit to keep the efficiency constant, even up to 30 kilohertz. This is a large number for this kind of instrumentation. And moreover, there is a system to use the extra voltage when the switch is opened, and we collect this extra voltage, properly manage and put to the counter electrode to generate the 1 kilovolts needed for our system. So it's an all in situ operation. The basket, the Richardson regime is used usually for vacuum diodes. Is well known from about 1,000, from over 100 years, and is Richardson work. Richardson effect is controlled from the temperature and the work function of the materials at the surface of the electrode. So we concentrated in values of working function as low as possible and stable. So the compromise is about materials with about 2 electron volts, like strontium oxide.
5 minutes, Francesco.
Only, okay, terrible. I suppose more. We have to accelerate the electrons. So we have high voltage due to Richardson law. This is the Pascal that show the dependence of breakdown discharge, changing the pressure and distance, and the hydrogen values these points. So we add some gas in order to have more comfortable voltage to start the reaction. Now we go to the new system. We add again iron oxide at the surface. So we have a capacitive discharge system with magnetic materials around. The electromigration itself can be kept at a high value. Now we work up to 95 watt just using pulsing. We have a very fast, like a calorimeter is a thermometer to be true, a dissipation type, because it has very short equilibrium, 30 minutes. We'll make a lot of tests, so we can use at the moment usual flow calorimetry, but we use later when all will be fixed. And we have found that when we moved from usual electromigration system, it means high pressure to the lower pressure that can enter in the Pascal regime, we have catastrophic destroy of the wire because the voltage was not under full control. So we were forced to study at the moment only electromigration to optimize the regime. And we found that the electromigration itself is able to have anomalous heat. This was observed before in 1986 with palladium, even with lower power. So it was for us like a confirmation, but we never before studied in details like now. The pulse has the power has a density of about 10 kilowatt per gram of material. The repetition rate was up to 2.5 kilohertz. Voltage current of the system, time now is short, I can go in detail. The main result a little bit complicated. Anyway, just using the pulse, we have a anomalous heat effect efficiency of about 4%. We are very confident about this point because we make calibration with the same wire, the same gas, pure hydrogen. So we compare the effect with the pulsing and in the C condition. This other curve show the effect of anomalous heat effects inside of the coil and outside the glass reactor. So we have found that inside the effects are stronger. So, but not all the thermal energy is thermalized from the glass. So we don't know why. So maybe some energy is lost and the glass is not enough to thermalize all the energy emitted. The internal is over 50% better than external. Here is the most important result. I spent the last minutes for this point. In the point black and red, here is the initial wire that never get before pulsing. We just have a cleaning wire and put hydrogen at 5 bar and make a calibration. This is the curve of delta voltage over power, the efficiency of the system. So this is a curve as expected, and this is the external temperature efficiency as internal one. The second experiment was done after we make pulse, about 20 million of pulse of 10 kilowatts to the system. So we repeat again the experiment. Again, clean hydrogen was the same, to be sure, but after we observe something strange. So we move to mixture of hydrogen and argon in order to increase the temperature and cross-check the data. So we have seen an increasing of the external temperature because the gas is argon less conductive, so it was expected, and in increasing of efficiency of the temperature is external. So internal temperature increase is expected. This one is not expected. There is energy gain just because before and after pulsing. So it was quite a big surprise or a reconfirmation what we have observed with pure hydrogen. So we make the last step. We try to deload completely the wire of hydrogen that before obtained because pulsing, and reducing again the amount of hydrogen in order to stress the high temperature effect inside. It was happened. So this experiment, the wire was almost diluted, but we found outside higher effect expected, just gas effect, but inside the temperature was lower. So it means that after the loading, the temperature increase outside is lower than the effect when the wire was in the full performance due to the pulsing. So this is really unexpected. Anyway,
Francesco, you're 2 minutes over. Please go to your conclusions.
Okay. So this is the most important aspect. Conclusion, we are able to use low-cost material, Constantan, instead of palladium, 3,000 times cheaper. We can work up to 600 degrees, but we expect more results going to 700, where the Richardson effect will be stronger. We found a procedure just by chance to activate the wire. From a theoretical point of view, maybe our system is not too far from model of Leif-Olmlid. And we are confident because we can go over in our system. We are going toward the practical application of LENR-AHE effects by low cost, low polluting material, and simple procedure, and in situ operation. Several people have helped us during our experiment, usual North-Est company of Italy, and one small group in Rome that give us money for a conference, mainly. Some special tube of alumina gained from Franco Corradi. We collaborate in a European group, so thanks to Kordachevsky, very elastic to our experiment, and we go hosted in Sweden, and especially Anders Kovacs from Broadbit. This experiment is done with some support from European community, and obviously the report is only what we think. It's not only, it's not an opinion. I stop.
Thank you very much, Francesco. I'm afraid we do not have any time for discussion, so I suggest you think of your questions and contact Francesco offline or at the discussion session at the end of the day. We must move on now.
So, okay, discussion.
No.